Next topic is crystal field theory. Okay, crystal field theory, CFT. In short, I'll discuss about this. What happens is that splitting of the energy of the d orbital takes place. Like d orbitals, which are the d orbitals? Let's say this is the energy of the d orbital without ligands. Ligands are not there. Means you take any d block element, and this will be the energy of the d orbital. It is at like this is the energy graph I am writing. This is the energy level. Okay, and at certain energy, all these orbitals will be there. dxy, this is dyz, this is dzx, this is dx square y square, and this is dz square. Okay, so here there is a splitting of the d orbital. 1 minute. Splitting of the d orbitals, like in the presence of the ligand. When ligand approaches, what happens is that certain ligands goes to higher energy and certain ligands goes to lower energy, like dxy, dyz, and dzx. This is dx square, y square, and dz square. When this is in the presence of ligand, there is repulsion, certain kind of repulsion, and repulsion is maximum with respect to dx square, y square, and dz square. If you see, what is the reason for that? This is along the axis. These orbitals are along the axis. These orbitals are in between the axis. So it is splitting into two, right? This whole energy is called as delta naught. Okay, this is CFSE, crystal field stabilization energy. So if I write this will be 3/2 times delta naught. Okay, so and this will be 1 minute. I forgot the values. Those values are, yes, 3/5. I mean, yes, 3/5 times delta naught. 3/5 times delta naught, and this is this gap from here to here is 2/5 delta naught. So together it is delta naught. Okay, this orbital, this energy level is called as T2g. This is T2g and this is EG. This is for octahedral splitting. Okay, based on this, we'll do one question. So this question is asked, what is meant by crystal field splitting energy or crystal field stabilization energy, means CFSE. Okay. On the basis of CFT, crystal field theory, write the electronic configuration of delta naught greater than delta P greater than P and delta naught less than P. Means what? P is a pairing energy. I will discuss about that. So, what is meaning of this? What is the meaning of this? Answer. You should be writing in an exam, right? The proper answer. So, definition. When ligand approaches a transition metal, you write this. When ligand approaches a transition metal in a definite geometry, the degenerate means what? Orbitals were having same energy initially, then they split, right? So degenerate d orbitals splits into two sets, means one set is dxy, dyz and dzx, that is in a T2g level, and higher energy will be dx square, y square and dz square, right? One with lower energy, and other with higher energy, and the other with higher energy. The difference of the energy, the difference of energy between two sets, that is T2G and EG. Okay, two sets of d orbital is called this crystal field splitting you write, or stabilization, one and same, splitting energy, right? Now what is the meaning of delta naught greater than P? Delta naught greater than P means what? Strong field ligand. They have told you about a D4 configuration. Like there are 4 electrons in d orbital. So strong field ligand means what? This gap is high. This gap between T2G and EG is large, right? So what happens? Electron cannot go on the top, right? So whatever 4 electrons are there, 1, 2, 3 and 4th will pair up. That's why it is said in strong field ligand pairing takes place. In weak field ligand pairing doesn't take place. Why? So when delta naught is less than pairing energy means what? Weak field ligand. Okay. Now configuration is asked, no? So what you will write is T2G 4 and EG 0. Like this is how it is splitting. Okay. I'll clean this part to show you delta naught less than P means weak field ligand. So here the splitting is very less, like gap is not so big. Here gap is very less, means 1, 2, 3. This is T2G, this is EG. There are what? 4 electrons, 1, 2, 3 and 4. Right, so D4 configuration is written as a T2G3 and EG1. So this is how the things are written for a crystal field theory. So we'll end the revision of coordination compound over here. Next video, let's come up with a new topic. Thank you.